So, hello guys, today we are going to discuss this problem, lead code problem number 53, maximum subarrays. So, the problem says that we are given array in which we have to find the sum of the largest sum of a subarray. So, the difference between the subarray and there are two terms actually, subarray and subsequence. Subarray means a contiguous elements, that is subarray is contiguous sequence of elements while subsequence can be non-contiguous. So if we see in this case, let me open a notepad. So if we see in this case, what all possible subarrays can be. So subarray will be -2, then it will be -2 and 1. Then it can be -2, 1, -3. Then let me copy it. Then it will be 4. Then it will be again -1 and so on, right? So if I take this example here, yeah, this one. So what all can be the subarrays here? Uh, for example, this. I have taken a array, something like this. So these are all possible subarrays. So 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 4 minus 10. And then starting from 2, we can have 2, 3, 2, 3, 4, and 2. Then starting from 3, we can have 3, 4, and then starting from 4, we can have um, this one 4 minus 10 and then finally minus 10. So we have to find the largest sum out of it. For example, if we see here, this is the subarray which has the largest sum, which is equal to 6. All the subarrays will have a sum smaller than this. So there can be two approaches. So one approach is the basic brute force approach, in which we will be taking two for loops, two nested for loops, and we'll find all the subarrays and find those sum. So for example, the code on the left, how we are doing is we have this array, something as this. So we have taken uh, output something as max, and then what we are doing is we are going to each element. So first I equal to 0, we are going to 1, and then we are having a temporary element sum, and then we are calculating all the subarrays, and we are just checking if sum is greater than the max or not. So we are taking two for loops. We are sticking on the first element, then we are finding all the subarrays of it, and while after finding all the subarray sum, we check whether the sum is greater than the present stored sum. Then in that case, just replace it. So we have to do recursively for all the subarrays. So it will be O(n) square solution because it has two for loops. The another solution is a Kadane algorithm. So in Kadane's algorithm, the concept is very simple. We start with uh, the max here element, or we can say a sum element, and max here represents the maximum sum till the present element. And if the max here plus the present element is smaller than 0, in that case, we'll do it 0. So for example, let's see here. Let us take this array, and these are the indexes. So these are the indexes, and this is the array. So at I equal to 0, what will be our max here? Max here is 1 because we start. So initially, max here is 0. At I equal to 0, we what we do is 0. So this condition, max here plus present element. So max here plus present element is 1. So at I equal to 1, our max here was 1, the present element is 3, so it becomes 4. That is 3 plus 1. At I equal to 2, we found that 4, which is our max here, minus 6 becomes smaller than 6. So this is minus 6 plus 4 becomes smaller than 0. So in that case, just initialize to 0. Then at element 3, what we have max here 0 plus 9, which becomes 9, that is 0 plus 9. Then at element 4, we have minus 10, so it becomes 0 again because minus 10 plus 9 is smaller than 0. Then again at 5 it's smaller than 0. Then at index 6 it's minus 3 smaller than 0. Then at index 7 it's 6. So the max here was 0 plus 6 and it becomes 6 only. So let me note down the max here what we calculated, and let us try understanding what it is. So if we see here max here, this is the maximum sum till index 0. If we see max here at index 1, so this is the maximum sum till index 1. Now we see that um, at minus 6, what is the maximum sum at this element, right? So it is, we have taken it as 0, but if we see the maximum sum before this element is 4, so we need not to make it as minus 1 or something, because that's irrelevant. And now if we see, we want to find the subarrays, right? Uh, sum of largest subarray. So if we continuously add these all the elements, so uh, 3 max element. Yeah, so if we continuously add these elements like 1, 3, minus 6, and 9, so in that case, the sum will be equal to 12, 13 minus 6, 7. But the subarray 9 has the maximum sum as 9 itself. Then till this element, what will be the maximum? So it will be negative. All these elements add up to negative. So we have taken it 0. Now again, for the index 5, all these elements will add up to negative. We have taken 0 and again 0. And for this one, it's 6. So while going through, we can just note the max here element in our um, out element, and that's the output is. So this is a ON solution. The only concept here in the Kadane's algorithm is we this condition, that if the max here plus present element is smaller than 0, just make it 0. Otherwise, add max here and the present element. That's it. Um, Thanks a lot. Have a good day.